Before we start the actual content of this presentation, you should know that this video has been recorded for use in more than one class. As a result, there may be some things in this video that do not apply to the specific class that you are taking. Please just consider that an added bonus at no extra charge. This particular presentation will cover a number of financial tools used in valuing bonds, corporate and other. I should also add that the formats have been pre-entered into this video to save time on the video. You most likely won't have that luxury if you are doing this in the real world. So let's get started. As I say in all of my videos, the uses and workings of these tools and principles are explained in your textbook or on the web. These videos are just to show how to calculate the numbers and to show in what format the numbers are usually presented. This first problem has multiple uses. The usage that is being shown is to determine a fair price for a bond. This also calculates a dollar value yield to maturity. Further on in this video, the method to calculate a percentage yield to maturity is also covered. For this particular problem, there are two ways being shown to calculate the yield to maturity. The first method is the most complicated, but it is probably the one that is of the most use, as the second method is tied to analyses only using complete years. If the settlement date and the maturity date are not exactly a year or multiples of years apart, the lower method will not produce accurate results. As usual, filling in the data needed for the Excel function is the first step. Since the problem is in complete years with no specific dates, any settlement date, meaning the date that the bond is being purchased, is fine. For the sake of this example, 1/1/2017 is entered into the workbook cell under settlement date. To achieve the goal of 10 years, add 10 years to the settlement date and enter that into the maturity date workbook cell. For the sake of this example, 1/1/2027 is entered into the workbook cell under settlement date. Most corporate bonds sell at a par value or a face value of $1,000. Into the workbook cell under FV, enter $1,000. The coupon rate as listed on the face of the bond is 6.25%. Into the workbook cell under I, enter 6.25%. The problem states that the yield to maturity of the bond is 7.5%. Enter 7.5% into the workbook cell under YTM. Finally, most corporate bonds pay interest twice a year. Enter 2 into the workbook cell under Freak. The formula to determine the price of this bond is shown 2 lines down. Highlight the workbook cell under Price. Type an equal sign followed by PRICE and an open parenthesis. Highlight the 1/1/2017 and enter a comma. Highlight the 1/1/2027 and enter a comma. Highlight the 6.25% and enter a comma. Highlight the 7.5% and enter a comma. Highlight the $1,000, type a slash denoting division, type 10 and enter a comma. Highlight the 2 followed by a comma, a close parenthesis, and a star denoting multiplication, a 10, and press enter. The yield to maturity in dollars is $913.15. Just as an FYI, the reason the $1,000 is divided by 10 is that Microsoft created this function assuming that a bond would have a face value of $100. By dividing by 10, the face value fits into the function paradigm. After the function has finished its work, the multiply by 10 at the end reflects the actuality of a $1,000 bond. You should also note that while this example used exactly 10 years to calculate the yield to maturity price, any dates can be used within the formula as long as the maturity date is after the settlement date. The second formula is much simpler and demands that you buy your bond on the same day and month that it matures some years later. Using the same numbers which were filled in automatically using cell references, the present value is calculated. There is a formula in the workbook cell under semi-annual payment that multiplies the face value of the bond times the coupon amount and divides by 2. This computes the semi-annual payment amount. As listed below PV, enter the formula into the workbook cell directly under PV by starting with a minus sign. Type in PV and type in an open parenthesis. Highlight the 7.5% and type in a /2 followed by a comma. Highlight the 10 and type in an *2 followed by a comma. Highlight the $31.25, type in a comma, highlight the $1,000, type in a comma, type in a 0 followed by a close parenthesis, and press Enter. The minus at the beginning of the formula is to be sure that this function returns a positive number. Bonds are not purchased with negative dollars, and mistakenly portraying them that way would be unprofessional and would not reflect well on the person doing it. The next problem is so simple as to almost be embarrassing. It builds upon the formula to value a corporate bond yield by adding the T-bond yield, the default risk premium, and the liquidity premium on the corporate bond. All this does is turn the formula around to solve for the liquidity premium on the corporate bond. From the verbiage of the problem, enter 8.5% into the workbook cell under corporate bond yield, enter 2.5% into the workbook cell under T-bond yield, and enter 5% into the workbook cell under default risk premium. In the workbook cell under liquidity premium on corporate bond, enter an equals sign, highlight the 8.5%, type in a minus, highlight the 2.5%, type in another minus, highlight the 5%, and press Enter. The liquidity premium turns out to be 1%. Again, a very simple solution. The last problem on this video shows how to calculate the percentage yield to maturity on a bond using the Excel rate function. This is another function that relies on even numbers of years. To approximate a percentage yield to maturity, a decimal representation of the number of years to maturity should provide a close approximation. In the investing world, brokerages will list bonds showing both the coupon rates and the yields at any time. To save time, the relevant data has been entered into the line where the formula will be calculated. The data is all in the word problem, and the calculation uses the rate function. In the workbook cell under Rate, type an equals sign followed by RATE and an open parenthesis. Highlight the 6, type in an asterisk, highlight the 2, and type in a comma. Highlight the $1,000, type in an asterisk, highlight the 4.5%, type in a /, highlight the 2, and type in a comma. Type in a minus, highlight the $975.85, and type in a comma. Highlight the $1,000 and type in a comma. Type in a 0 and a closed parenthesis, followed by an asterisk. Highlight the 2 and press Enter. The percentage yield to maturity for the described bond is 4.97%.